Here's just a couple more examples of stoichiometry problems. I'm going to do 4 different examples, okay, because there's 4 different types of problems. So the easiest problem is a moles to moles problem. So when I say moles to moles, it means I'm giving you moles of one thing, we're working our way to moles of another thing, or maybe moles of all of them. Okay, so if you know one of the things in this reaction, if you know how much of this was used in the reaction, you should be able to tell me how much of that was made, how much of that was made, and how much of that was used with it. Okay, so there's moles to moles. You can go moles to grams, so like moles of this to like grams of that. You can go grams to moles. I could give you grams of one of these. You can finish with moles of one of these. And I give you grams to grams. Okay, so we'll start off with just the moles to moles. So let's say that 27 moles of CO2 are produced in this reaction. And I want to know how many moles of O2 would have been used to make that. So start with 27 moles of CO2. Anytime you start with moles in these problems, we're always going right to our mole ratio, our mole to mole ratio, which in this case is a 3 to 5 ratio. The thing you're going to always goes on top. So we're going from this to this, and our labels have to cancel. So for every 3 moles of CO2 that are used in the reaction, or excuse me, that are produced in the reaction, there's 5 moles of O2 used. So we just take 27 times 5 divided by 3, which is 45 moles of O2. Now I could have gone to anything. So if I was going like CO2 to water, I would just change this to 4 moles of water on top. If I was going CO2 to C3H8, change this to 1 mole of C3H8 on top. So that's a moles to moles problem. If it was a moles to grams, so let's just say it was moles to grams. So instead of saying moles to moles, let's say we want to know how many grams of oxygen it would take. So we do the same thing. Start with 27 moles, we do our ratio, which gets us to moles of oxygen, so those cancel. And then we just got to do moles to grams. Moles of oxygen to grams of oxygen. So that's just saying, okay, what does a mole of oxygen weigh on the periodic table? So we're not using that ratio anymore. We're just saying, what does 1 mole weigh? And a mole of O2 on the periodic table weighs 32 grams. That's 2 oxygens on the periodic table is 32 grams. Again, this label cancels. So to get this answer, we would take 27 times 5 times 32 and divide it by 3. Okay, it's going to be a big answer in the thousands of grams because this is quite a few moles. All right, so there's 2 types of problems, moles to moles, moles to grams. The next ones we'll start with grams. Okay, next ones we'll start with grams. So let's say that we use 88 grams of propane, and I want to know how many moles of oxygen would be produced. Now let's not do oxygen. Let's do a different thing. Let's do moles of water. How many moles of water? So it could be any of those things. How many moles of water would be produced? So we're going from propane to water, starting with grams. So if we start with grams, we got to get to moles first. So we need to get grams into moles, and that is grams of propane and moles of propane. So we just look at the periodic table and go, what does 1 mole of propane weigh? We add up 3 carbons. 12 times 3 is 36, plus that, 44 grams is a mole of propane. So if we take 88 divided by 44, that would tell us how many moles we have of propane. This cancels with this. Next step is since we're at moles, now we go to our ratio. In our ratio, we're going from propane to water. Propane to water. The ratio would be 1 mole of propane. For 1 mole of propane that's used in the reaction, there's 4 moles of water made in the reaction. Okay, in this case, we're asking for moles, so we are done. And we're at moles of water. So we multiply 88 times 4, divided by that. Actually ends up being, the answer would be 8 moles. The answer would be 8 moles there. Now, if it was asking for grams of water, so if it was a grams, asking us to go to grams of water, now we should do another step. We're at moles of water, so we just go moles of water to grams of water. And in this case, we don't put a 4 right here. We just say, what does 1 mole of water weigh in grams? So add up 16 for oxygen plus 2 for hydrogen, 18 grams. Multiply across the top, divide by the bottom. All right, kind of a quick video, but kind of tells you the 4 types of problems. Remember, if you start with moles, you go right to your ratio. If you start with grams, you convert to moles first, and then go to your ratio. You can either stop with your ratio if you want moles, or go next step and get grams.